All right, so let's talk about the scalar data types, the primitive data types that we have available for us in Rust. So here is the first one. This is the integer, and I have a table here that shows you which different sizes of integer are available. So as you can imagine, we have 8-bit integer, so we have I8 as a signed integer or an unsigned integer. The only difference is obviously this can have negative numbers, this cannot have negative numbers, okay? We have a 16-bit, we have a 32-bit signed and unsigned. Now this is in bold because this is the default value, the default type that is assigned to a variable when we don't declare the type, okay? So this is what the system assigns the variable as. Then we have 64-bit and 128-bit. Okay, this is the largest. Now we also have something that relates to the architecture of the machine where the program runs. And that is the I size and U size. And that basically gives a size of an integer depending on the size that the machine has. Now we of course have floats, okay, but here we only have two types of floats. We have a 32-bit and a 64-bit, the 64-bit being the default. Now, we can have typecasting. So typecasting basically means converting from one type to another. So for example, here, let's say I have pi as an F32. Okay, I declare it as an F32, and I provide a value 4. So the value 4 is an integer, it's not a float. So that will give us a mismatch type error. Okay, if we want to have a float here, we have to provide the .0 at the end. All right, so let's try that in our code. Let me just remove this. Let's say let's say pi as a F32 equals 4. That's obviously going to give us an error if I run this mismatch type. But if I put 0.0, okay, that works just fine. You might have some warning here, which I don't because I've added the allow unused variables at the top. All right, so that is typecasting. Now, of course, we can define any variables we want as an integer. We've already done that, or as a float. Okay, we've tried that in the past. All right, now, next up, we have a number separator. So we can, it doesn't really influence the value at all. The only difference that this number separator makes is that it's easier to read. So for instance, if we define a variable million, and that is 1 million, okay, that might be a bit hard to read, but if I put underscores, okay, something like this, that's easier to read, right? So I have 1 million here. Okay, so very, very simple. So if I print line that, and I'm gonna use the million here, I'm gonna get 1 million. That removes the underscore, obviously. Okay, now we have the third type, which is Boolean. Obviously, if you've used any other language in the past, you will know what Booleans are. We have true or false value. So let's try that in our code. We have let is underscore day equals true, and let is underscore night equals false. Very, very simple, very intuitive, right? So we're going to print line. Okay, and let me print one of them is day, and that should give us a true. All right, that is fine. Next up, we have the character. So the character is basically one single character. If you try to put multiple characters, you will get an error. Okay, so let's try that out. Characters are marked with single quotes. So I'm going to put let char1 equals a. Okay, so I'm going to print line the char1 here, and that will give us a. Now, if I have a b here, then that will give me an error because we do not, we cannot have more than one value here. All right, and finally, inside the character, we can also add, emojis. Okay, these are Unicodes. You can find these online. I've just added one for the smiley face here. Let's try that out in our code. Let me duplicate that. And the way you do that is /u and you put it in curly brackets here, 1F601. That's the code for one of the smiley faces. And if I print that, obviously we get the smiley face here at the console. Right, so that is all for our data types. And in the next video, we will talk about strings and the different types of strings that we have available to us.